Operating a surface fleet in open waters subjects sensitive technology to intense physical pressure. Saltwater corrosion, hydrodynamic stress, and unpredictable weather require platforms engineered for long-term durability. On June 21st, the Indian Navy commissioned INS Dunagiri. It is the fifth stealth frigate of the Nilgiri class, constructed under a program designated as Project 17A. The F-47 frigate docked here features a distinct, sharply angled exterior hull, which significantly reduces the vessel's physical profile compared to older platforms. For several decades, the Indian Navy's expansion was constrained by a reliance on foreign defense contractors. Advanced platforms were largely acquired through import-heavy procurement models. This dependency creates a strategic vulnerability. During international crises, foreign supply chains can become unreliable, potentially grounding a fleet that relies on imported components and maintenance expertise. Project 17A addresses this vulnerability directly. The Danagiri was built with 75% indigenous content, prioritizing domestic manufacturing over foreign purchasing. The Danagiri is a practical test of a new model for naval construction: the ability to design and build a complex combatant using a localized industrial base. This shift began in the design phase, which was executed entirely by the Indian Navy's Warship Design Bureau rather than an external firm. To build the ship, the Navy moved away from centralized foreign contracting and toward a distributed, localized network of suppliers. This animated map of India shows the extent of that network. Over 200 individual enterprises were responsible for fabricating the ship's components. Those thousands of locally produced parts then converge at a single assembly point in the east. That facility is Garden Reach Shipbuilders and Engineers in Kolkata. The scale of this industrial infrastructure allows for the simultaneous integration of these complex modules. Fusing hundreds of independent modules into a high-tolerance stealth hull requires extreme precision, ensuring that the ship's geometry maintains its radar-deflecting properties. This split flowchart compares procurement efficiencies. While the legacy import model is stalled by international logistics, the localized Project 17A network moves directly from fabrication to assembly. This domestic supply chain insulates the maintenance schedule from international sanctions or trade disruptions. Achieving a 75% indigenization rate on a platform of this complexity establishes a new benchmark for Indian naval architecture. This integration transforms defense spending into long-term strategic independence, ensuring that the fleet can be supported and maintained from within India's own borders. The primary defense of the Dunagiri is found in its physical shape, which was designed to minimize its visibility to enemy sensors. This wireframe model of the Nilgiri class highlights the deliberate angles and flat surfaces of the superstructure, designed to reduce its radar cross-section. When incoming radar waves hit these surfaces, the angles scatter the signal in random directions, rather than reflecting it back. While no ship this size is truly invisible, these stealth features delay detection, providing the Dunagiri with a tactical advantage during the opening stages of an engagement. If the ship is detected, it transitions to its secondary layer of defense, an active air defense system. This role is handled by the MRSM, the medium-range surface-to-air missile system, integrated directly into the ship's deck. The MRSM provides a protective envelope around the ship, capable of intercepting incoming aircraft or high-speed missiles before they can strike. The combination of stealth geometry and active missile defense provides a high degree of survivability while operating in contested maritime environments. Defense is only half of the platform's mission. The other half is its ability to dominate its surroundings through offensive weapons. This diagram illustrates the ship's kinetic envelope, a layered 360-degree radius where the platform can engage threats. For surface warfare, it utilizes BrahMos supersonic cruise missiles, hitting targets at extreme ranges beyond the visual horizon. This allows the Dunagiri to strike enemy combatants with high precision before they can move into their own firing range. For threats that appear at closer ranges, the ship is equipped with 76mm naval guns, capable of rapid fire against asymmetric or smaller surface targets. Beneath the surface, the ship maintains a different set of specialized tools for anti-submarine warfare. It carries advanced torpedoes designed to track and neutralize modern, quiet submarines that might be patrolling the area. To defend against incoming torpedoes, the ship also features dedicated rocket launchers that provide a final layer of protection for the hull. When required, these systems allow the ship to react instantly, launching supersonic ordnance that accelerates toward a target in seconds. By integrating the BrahMos system, rapid response guns, and anti-submarine tools, the platform maintains comprehensive coverage across all physical domains of naval combat. Managing these weapon systems requires an advanced internal digital infrastructure to process data in real time. This X-ray diagram displays the integrated platform management system, the central control core for the entire ship. It manages power distribution automatically and instantly routes damage control protocols without waiting for manual commands. This automation significantly reduces the physical and mental load on the crew, allowing them to focus on high-level decision-making. Reducing the crew's workload contributes to higher operational endurance, meaning the ship can remain deployed at sea for longer periods without returning to port. This endurance is critical for non-combat missions, such as long-term maritime surveillance or anti-piracy patrols in remote waters. The platform is equipped for disaster relief operations, where its ability to loiter near damaged coastlines allows it to coordinate aid and medical support. High levels of internal automation allow this heavy combatant to function as a highly versatile utility platform during peacetime or humanitarian emergencies. This map illustrates the operational context of the Indian Ocean. Notice the dense clusters of yellow tracking icons. They represent global shipping lanes passing through the Strait of Malacca toward Sri Lanka. Securing them requires ships operating over vast distances, far from their home ports. The Danagari's stealth and range allow it to monitor these corridors and, if necessary, deny access to hostile forces. Its localized supply chain ensures that the ship, and the fleet it belongs to, remains operational and resilient, even when international logistics are strained. By building these capabilities domestically, a Navy gains the ability to manage its own security requirements without relying on the approval or resources of foreign nations. The deployment of domestically produced platforms like the Danagari allows India to maintain a persistent and independent security presence across its most critical maritime interests in the Indian Ocean.